Okay, today we're going to get into chapter 6. It's timber yet. Of course, chapters 5, 6, and 7 are all related to wood or timber. So chapter 5, which we've already looked at, is timber in beams. Chapter 6 is columns. We have two flavors here. One is a post or a column. The other is a stud. We're not going to worry about studs. Studs are repeated members in walls of wood construction. So if you look at it, you end up with a wall built out of two plates at the top, a stud going down, and a plate at the bottom. So these repeat. So every 6, 12, 16, 24 inches, depending on the layout, you'll have a stud. These are pretty prescriptive. Anybody that's been in wood construction has a good feel of which one to use and where they go. It's nothing too technical. They're all pre-cut. They're all cut to a certain length. So all we've got to do is put them together like Legos. So those are studs. We're not going to worry about those in this. We're going to worry about a post or a column. So a post or a column is going to be a wooden member. It's going to be either square or rectangular in shape. Okay, the tables you're going to use for those are the same one you used before. You've seen it, you've used it already. It's table A8 on page 676 and 677. So if you go to table A.8, 676, 677, it's going to give you all the dimensional and area properties of a member. It's going to have things like area, physical size, and it's going to have a couple other areas there like moment of inertia and things like that. So if you look at it, it's got area, section modulus, moment of inertia, and density. So that's where you're going to get the data for cross-sectional properties. We've got chapter 6 is divided into 3 regions as far as I'm concerned and you're concerned. First is the use of an analytical tool to figure out the ability of that member to carry load. So we got columns, and we got one. We've got using an analytical tool, which is an equation to figure out the moment capacity. And if you look at any of this data, the moment capacity is going to be P. The axial load that's applied to it, P. Okay, so we can do it analytically. We have some common wood members that we can use, and we've got a set of tables that we can use for that. Okay, so unfortunately the table is got some specific requirements. So we have tables we can use, and then 3, we've got an analytical tool where the load is not on the center. So both of these are the load is on the set center line. It's going to go right dead center. Okay? The other one is a load that is not on center. So let's say I have a little haunch or something on this beam. I put the load out here. Here's the center. It's off center. Off center is eccentricity. We've already talked about eccentricity, so that shouldn't be a new concept to you. So analytical. So we got an analytical tool with a load on the center, analytical tool with eccentricity. So today, I hope to get us in a position where we've got most of these two whipped. This is a real fast one, okay? The table we're going to be using is going to be a table that's on page 244. It's table 6.1. Okay? So what I thought we'd do is we'd run a couple problems parallel. I'm going to do the problems that are the ones you're not going to do. You're doing A and B, F and H in this particular area. I'm going to do the opposite problems, but then I'm going to introduce you to another problem, the one that we can run parallel using analytical and table and see if we get the same answer. So let's take a look at it. Build up some data, some knowledge so that you've got a chance of doing these right. Number one, wood. We've already talked about it. I want to make sure you understand it. A 4x4. I'll use a 4x4 as an example. If you go to the lumber yard and you buy the piece of wood, you're going to tell them, I'd like a 4x4. If you take that 4x4 and you throw it in the back of your truck and you measure it, it's not going to be a 4x4. So that table that I told you to look at tells you that. It has the nominal, this is nominal, versus actual. If you take your tape out and you measure it, it's actually going to be 3.5 by 3.5. So that table is calculated based on what it is, not what it thinks it is. It's going to be, all those numbers are going to be developed off of this 3.5 by 3.5. Okay? So that's one thing. You got to understand that. Two, columns. If I take a column and I attach it to a ceiling and a floor, it's going to have some length. Okay? The length is what you would buy at the store. So I want a 4x4 by 12. That means I want a piece of wood that's nominally 4 inches by 4 inches and is 12 foot long. So I take it home and I install it. So the length is here. Okay, what if I have members, let's say I'm doing a pole barn or something like that. What if I have members that come across here and frame into it? Okay? Okay, it can frame in one direction or it can frame in both directions. I can have a member just come there and this side's maybe a big door here and you can't get a member in there. Or I could have another wall there and I bring the member into the side. What I've done here now is I've pinned it. There's the top and the bottom. I've put a support here. If I didn't have that support and I watched it buckle, it's going to, after a certain load, it's going to take a shape that looks like that. If you don't believe that, take a yardstick, put your hand on it and push down on it. It's not going to bust. It's going to buckle. Okay, so we got to worry about how skinny it is and its length. The combination of those two determine how fast it's going to buckle. So if I put that brace in here and it's tied here and it's restricted there, when I push down, it's going to buckle like that. Okay, so we have a difference between its real length and its unbraced length. Okay, unbraced length. If this happened to be a 12-foot long member and I put a brace in the middle, the unbraced length of that is 6 feet. The unbraced this is from top to bottom, 12 feet. What if I did this? What if I had that same thing and that brace that I was, member coming across needed to be above your head? So I had to put it at 8 feet. So I'm braced at 8 feet. That meant, there it is. Now I can walk underneath it when I walk into the building. Okay, if that's the case, now I've got a brace at 4 foot from the top, 8 foot from the bottom. if this buckles, it's going to buckle like this. Okay, hopefully you can see when I push down, the first buckle is going to be this one down below. It's going to take a lot more load to buckle a short member than it is a long member. So, in this one, the unbraced length of the member is going to be 8 feet. It's the largest unsupported or unbraced section. So you got to understand the concept of bracing. Bracing's big. We use it all the time. You could take a member and change its load capacity by a tremendous amount by just adding the proper bracing in it. So you got to understand lateral support. You got to understand the concept of lateral bracing. Even though it's 12 foot long, which this one still is, the unsupported length is 8 feet, not 12 feet. So that's that concept. You need to know that. Other than that, I think we can go. We're going to get into some other concepts that you're going to get in there in the equation. So this is analytical tool happens to be an empirical equation. So, empirical. What does empirical mean? Empirical means somebody sat in a lab, put loads on, tested the pieces of wood, and they developed a table of data, and from that table of data, they modeled it with an equation. So an empirical equation is an equation that was put together or developed based on data. Okay? So you're not going to quite understand it. I don't expect you to understand the concept totally. In theory, I want you to understand the basic concepts. The theoretical concepts are lab-based, and you're not going to test this in the lab, so I wouldn't expect you to grasp those. So this particular part, this one, analytical are going to be managing data more than it is understanding concepts. And this is just reading a table. So the table is pretty simple, unfortunately. Like any table, you got to understand what the person who developed the table was thinking. So you got to read all the footnotes around the table so you don't assume what you think is right and miss the intention of what the developer was thinking. So if I look at this thing, and I look at table on page 244, we're going to use the table quick because that's the fastest. Then I'm going to go ahead and do the analytical. If you look at that table, it's got nominal size, it's got the area. We would use area in our class to find out which is the least expensive. The least expensive is, of course, is the one with the least area. There's the unbraced length, okay? In the field is the amount of load that particular member can carry at that particular unbraced length. But you got to remember this, look below it. The load capacity for in kips of solid sawn, now here's the kicker. When we went through the table, we had grades, we had species and grades, okay? In this particular chapter, our species is going to be Douglas fir larch, so you don't have to worry about it. But our grades are going to vary. We've got several grades as you saw before. So this particular table is developed for only one grade of Doug fir. And if you read it, it says number 1. So here, you got to have a star. This is a big problem on the test. This is number 1 Doug fir larch. So if it's number 1 Doug fir larch, you can use the table. If it's any other grade, you can't. So on a test, read the problem. The problem says number 1, you want to go to this table. If it says anything else, you have to go to the analytical tool. Okay? So let's take a look at a couple problems. It's quick, it's easy, not much to it. If you look at it, it's letters E through H. So 6.2E through H. So I'm going to do all but F. Oh, no. E, F, G. I'm going to do E and G. Okay? You're going to do F and H. I'll do E and G. So I got a load, P. For letter E, that load is 20 kips. For letter G, that load is 50 kips. For letter E, the unbraced length is 8 feet. And for G, it's 20 feet. Okay, this is pretty tough, so hopefully it's so simple. Don't make it so simple that you miss the obvious and screw it up on a test. Okay, here's all you do. Turn to page 244 and turn your book so you can read the table. Okay, what I want you to do is put your finger on 8 feet. Wander down until you hit the first number that is equal to or a little bit larger than 20. 7.28, 11.4, 15.1, 24.8, first number. Go to the left, 6 by 6, write it down, and you're done. Next one, go to the table, put your finger on 20 feet. Head down the column and stop when you get the number that is equal to or a little bit bigger than 50. 7, 9, 13, 23, 29, 35, 52, 52.9. Go across and it's a 10 by 10. And if I wanted to write, which I would like you to do actually, an 8 of 6 by 6 at 8 feet carries 24.8 kips. And a 10 by 10 at 20 feet carries 52.9 kips. There's your answers. That's it. And that's all there is to it. Okay? That takes care of this one. Okay, the next one is to use this over again, and the problems that you're going to be doing are A and B. So I'm going to take a look at the problems. If you look on page 242, it has A and B. I'm going to do C, and once I have C, then we're going to do one more with number 1 and use both